Hello friends, welcome to the session. I am Dr. Nandakishore Suryavanshi from Art Science and Commerce College, Chikaldara. Today we are going to discuss the point water and wastewater treatment. Water is essential for every life. So the quality as well as quantity of clean water supply is of very much importance for all the living organisms. This water therefore must be treated before use. The purpose of water treatment is to remove the contaminants that is pollutants from the water so that the water will become of acceptable quality. The quality depends upon whether water will be reused or discharged. There are different methods of water treatment. In this part, we shall see the preliminary and primary treatment of water. In preliminary treatment of water, gross solids like large floating and suspended solid matter, oil, grease, and grit are removed from water if they are present in considerable quantity. Grit means sand and stones. Large quantities of floating clothes, wood, and other larger objects are removed by metal bars. Under these bars, the wastewater flow in an open channel. Removal of gross solid is generally carried out by passing the wastewater through mixed or moving screens like bar screens, rank screens, drum screens, wire rope screens, and etc. Sometimes gross solids are cut into small pieces. Grit is removed in the early stages of water treatment to protect the pumps. As grit is heavier than organic solids, it is separated from organic solids by regulating the flow velocity of the water in the grit tanks. Grit settling chambers are useful to separate the grit. The separated grit is then used for land filling and road making. The oil and grease present is removed by passing the wastewater through skimming tanks where oil and grease are skimmed off. This process can be carried out more efficiently by aeration, chlorination, or vacuum flotation. If the oil and grease are in their emulsified state, then they may be removed with the help of chemical reagents in primary sedimentation tanks. The preliminary treatment is followed by primary treatment. After removal of gross solids, gritty materials, and excessive oil and greases, the next step is to remove the suspended solids as much as possible. This step helps for easiness in secondary treatment of water. First step is sedimentation step. The suspended matter can be economically and efficiently removed by the sedimentation. This process is useful for wastewater containing higher percentage of settleable solids. The sedimentation tanks are designed in such a way that the smaller and lighter particles settle under gravity in it. The settled sludge, that is material deposited at the bottom, is removed from the sedimentation tank by mechanical scraping into the hoppers and then pumping it. In a well designed sedimentation tank, about 50% of the suspended solid within 2 hours of detention time. It is expected from an efficient sedimentation tank to remove about 90% of the suspended solids and 40% organic matter, and thus reducing the biological oxygen demand. In wastewater having large quantity of industrial wastes, long detention time is required to mix and balance the various wastes. This also helps to safeguard or protect the biological purification plants from heavy load. Filtration is the second step in primary treatment. Filtration is usually the final step in the solid removal process, which begins with coagulation and advances through flocculation and sedimentation. In the filter, up to 99.5% of the suspended solids in the water can be removed, including minerals, floc, metals, nitrates, and microorganisms. Filtration consists of passing the water through various screens or medium such as sand and filters. Sand is nature's one of the most effective water filters. As the water passes through the filter, flock and impurities get stuck in the sand and the clean water goes through. The filtered water collects in the clear well where it is disinfected. Sand filters are generally used with the combination of activated carbon or anthracite coal filters, which are efficient in removal of unwanted taste and odors. There are also biological filtration methods that use living organisms such as plants and bacteria in order to filter water from toxic ions and unwanted matter. Four mechanisms have been found to be part of the filtration process, that are straining, adsorption, biological action, and absorption. In straining, the water is passed through a filter in which the pores are smaller than the particles to be removed. In adsorption, the gathering of gas, liquid, or dissolved solids onto the surface of another material can be shown in the figure. While in biological action, any sort of breakdown of particles in water. The third step in primary treatment is coagulation step. Coagulation means treatment of water with coagulants to remove colloidal and coarse dispersed impurities present in the water. In this, the sewage or the other wastewater is treated with certain chemicals, that is coagulants, which form a flock. This flock absorbs and then carries the suspended and colloidal particles. Since the colloidal particles carry some charges, so their charges can be removed by mutual coagulation of oppositely charged particles of colloids. The commonly used coagulants are hydrated lime, alum, ferric chlorides, and so on. Alum is the most popular coagulant used both in water and wastewater treatment. For best results, the chemicals used for coagulation are well mixed with the wastewater in baffled channels, followed by mechanical flocculation before sedimentation. Coagulation is the most effective and economical method to remove the impurities. Sometimes, in addition to coagulants, other chemicals like activated silica called coagulation. The fourth step in primary treatment of water is sterilization. Sterilization is the process that eliminates, removes, or kills all the forms of microbial life, including bacteria, fungi, viruses, and spore forms, etc., present on a surface, in a fluid, and in a compound. That is, sterilization is the destruction of all microorganisms, while disinfection indicates the destruction of all disease causing microorganisms. Sterilization can be achieved by applying heat, chemicals, irradiation, high pressure, and filtration. However, disinfection procedures applied to wastewaters result in reduction of all microbes so that bacterial numbers are reduced to a safe level. In general, disinfection can be achieved by any method that destroys pathogens. A variety of physical or chemical methods like ozonization, chlorination are capable of destroying microorganisms under certain conditions. Physical methods might include heating to boiling, or incineration or irradiation with ultraviolet rays or X rays. This sterilization process can be carried out with the help of various methods like ozonization, chlorination, and UV irradiation, and so on. So let's first see what is ozonization. In ozonization, the drinking water is treated with ozonized oxygen in a tower made of enameled iron, which is divided into many compartments having perforated celluloid partitions. Ozonized oxygen and water to be treated are passed through separate inlets provided at the bottom of a tower. The sterilized water is collected at the top and the perforated partition breaks up the gas and water into minute bubbles. This can be explained with the help of the figure. Water can be sterilized with the help of chlorination method. Chlorination is probably the best and cheapest method of sterilization of water. In this, chlorine may be used directly in liquid form or as hypochlorites, that is in the form of bleaching powder. Here, water and chlorine react with each other and form hydrochloric and hypochlorous acids. This hypochlorous acid formed in the reaction penetrates through the organism cell and destroys it. The another method of sterilization of water is UV irradiation or ultraviolet irradiation. In this process, the water to be sterilized is exposed to ultraviolet radiation in specially designed chambers that provide intimate contact of water with bacteria and other living organisms absorb the energy which destroys or inactivates their DNA, thus preventing the bacteria from reproducing. Similarly, chemicals and organic compounds also absorb the energy, but they are broken down into smaller and more harmless molecules. Thank you.